Okay, for this problem, number 5, worksheet 4, had students do it in a very interesting way, a very easy way. I'm not going to do the easy way. I will attach their picture so they can get credit. You can see that down below. But I want to do the way that I did it to be fair. Plus, I imagine this is the way that most students would probably attempt to do it. Okay, so I'm going to draw a free body here. I'm trying to figure out this distance d. So here's my free body. I'm doing it for the bottom board. And let's put in the forces. There would be a weight force from the bottom board right about here, right in the center. There would be a support force right at the pivot point, so right about here. And there would be another weight, there would be a reaction to the weight force on the bottom board from the top board, and that's going to be, I'll put it right here. I didn't draw these to scale or anything. Okay, so this is going to be the weight of the bottom board. I'll say weight 1 from Earth. This one right here will be the reaction force to the weight, so I'll call it the normal on 1 from 2. This right here is the support force on the fulcrum, on the board from the fulcrum. Okay, so I know that NBF must be equal to W1E plus N12, and so NBF must be equal to 10 newtons plus 40 newtons. So I can figure out this NBF. That still doesn't help me figure out the distance though. So let's see if I can kind of come up with a torque equation. I chose the pivot point to be here in the middle. There are better places to put it, but that's where I'm going to go ahead and put it at. So for this, my torque equation becomes the torque from 1 will be equal to the torque from 2, which would be weight 1 E times the distance away. I'm just going to call this R1 for now because I don't know it, times the sine of 90, which is just 1, equals the force on the other side, which is N12, times its distance away. I don't know this one either, so I'm going to call this R2 times sine of 90, which is 1, so I'm going to drop that off. I could even go a little bit further here. The weight 1 is going to be equal to 10 newtons. By the way, this is 1E, 10 newtons, times R1, which I don't know what that is yet. N12 is going to be 40 newtons, times R2. Okay, so I have two unknowns here. I don't really know either one of them. So I need to figure out the distances. Well, this distance right here, from here to here, that's 1 meter. Okay, so if this is 1 meter and this whole distance here is d, then that means that this distance from here to here, that green distance must be equal to, so R1 I'm talking about, R1 must be equal to d minus 1 meter. Okay, And then I also need to know the distance from the center of this one to here. Well, if this distance is d, and this distance here is half a meter, so that distance there is 0.5 meters. Then this distance in between must be equal to 2 minus d minus 0.5. So R2, you're killing me. Okay, so R2 must be equal to 2 meters minus 0.5 meters minus d. Or said another way, R2 must be equal to 1.5 meters minus d. Okay, so I'm going to come back over here now, and I'm going to plug that in. So I'm going to have 10 newtons times the quantity d minus 1, and I'm going to have 40 newtons times quantity 1.5 meters minus d. So I can divide by 10 on both sides, and I have d minus 1 equals 4 times 1.5 minus d. I can multiply that out. I get d minus 1 equals 6 minus 4d. And add the 4d to the other side, so I have 5d equals 7. And then I can divide both sides, and I get d equals 1.4 when I solve that. So d equals 7 divided by 5, which is 1.4 meters.